chemical bonding? Yes or no?
No, sir, actually I was not there in previous class. Maybe two class I didn't join.
Okay.
Good evening, sir.
Good evening, Rishita. Just wait a minute. So, have you revised chemical bonding, Rishita?
Yes, sir.
So, wait a minute. Let me. There it is. There it is. Colors. Chemical bonding. So, chemical bonding is completed in your regular class, right?
Yes, sir.
Very good. So, let's just start with very basic question. Let's just start. Okay, you are aware of this octet rule, right?
Yes, sir.
If you have any doubt in any concept, you can ask me as well. Wrong it is. Bond formation means force of attraction, and force of attraction should be more. And when bond formation takes place, energy release, that means potential energy we are talking about, it should be minimum. So you told me B, minimum attraction, that is wrong. It should be maximum. If minimum potential energy will be there and maximum attraction, then only bond formation will take place. So the answer will be 3. Attraction is not minimum. Are you getting my point?
Yes, sir.
Yes.
Octet rule means what? Octet rule means basically 8 electrons in the outermost shell. And you know, octet rule is followed by strictly, that is followed by second period element mostly. Second period element. Sodium it will follow because it is a metal and it will lose and have 8 electron in the outermost shell. Fluorine second period element. Hydrogen duplate it will form. So comes out to be sulfur. Sulfur is a non-metal which will be in SF4, SF2 and SF6 as well it forms. So basically sulfur third period element does not follow, generally does not follow this octet rule because it has vacant d orbital, so it can maximize its covalency. So the answer will be third. If you are not able to do this, just let me know. Okay, fourth B, very good. Any other answer?
Doing, sir.
Very good, Rishita. The third one is correct. Very good, Akib. The fifth one is correct. Oh no. Expanded octet, that means more than 8 electrons. SF6, it will make 6 bond. That means one bond contains 2 electrons. So 6 bond, that means 8 electrons. Sorry, 6 bond, that means 12 electrons. PCl5 makes 5 bond, right? You know the PCl5 structure is very important.
Yes, sir.
So how many bond is there? 5, that means 10 electron. More than 8, that means it is expanded. H2SO4, if you know how to draw the structure of H2SO4, you can see this is the structure of H2SO4. How many bonds sulfur is making here? You can see 2, 4, 5, and 6. It is also expanded. So all of these are expanded octet. I'll keep waiting for the third question.
Yes, sir. So I don't know third one.
Third one, it is saying that which one of is an exception to octet rule. Octet rule means what? Octet rule means basically 8 electrons in the outermost cell. Okay, not an
Yes.
option, not an exception. BF3 making 3 bonds, 6 electrons, so it is an exception. BeCl2 2 bond, 4 electron, it is also an exception. ClO2, see ClO2, it will make bond like this. Okay, so it is also not an exception. It is also an exception because ClO2, you can see the structure will be like this. Fluorine has 7 electrons in the outermost cell, so 1 lone pair and 1 electron. So SiCl4, if you are going to do the structure of SiCl4, you know outermost cell, it will have 4 electron. So 4 bond it is making. 4 bond, that means 8 electrons. So this is not an exception of. Are you getting my point?
Yes, sir.
So can I move to the next question?
Yes, sir.
Yes, sir.
Very good. Wait a minute. Okay, do it. These are very basic questions. Very good, Rishita. Very good, okay. Any answer? If you're not able to solve it, just let me know. I'll explain it. Okay, I'm going to explain the concept behind this. Yeah, you didn't revise it, right? Akiv and Rishita.
Sir, isn't lattice energy?
Are you saying for the third question, right? Born-Haber.
Yeah.
Yeah, it is lattice energy. The second one, see the second one. Ionic bond formation involves overlapping of orbital is that means basically sharing of electron. Electron is present in this here and another electron here, then they will share with each other like this. Okay, so it cannot be the answer. And loss or gain of electron take place, so there will be no elimination of proton or sharing of electron or overlapping of orbital. This means same. Completion of octet takes place by losing or gaining transfer of electrons, so the only option here will be left, that will be 4 is the correct answer. Is that clear?
Yes, sir.
Now
Yeah.
next one, the fourth question, what is? Any answer for the fourth one? In ionic compound A plus B minus, that means basically you can write it as AB, most likely to be formed. You know that A goes into A plus, that means it will lose electron. You took out the electron. It is known as ionization energy, the energy that you use to take out the electron, ionization energy. And if you want to form an ionic compound, you want to spend minimum energy to take out the electron, that means ionization energy should be lesser. Okay, and this B is in negative, that means electron gains and it forms B negative. So electron gain enthalpy, after gaining electron, it should be stable and release more energy in order to become stable. So ionization energy of A is low and electron affinity, that is your electron gain enthalpy, is high. So both 1 and 2 is correct. Are you getting my point?
Yes, sir.
Let me know the answer for the fifth one. Any answer?
No, sir.
Okay, as compared to covalent bond, electrovalent compounds generally, electrovalent compound, due to the force of attraction due to the charges, the bond electrovalent compound, that means ionic compound, are more stronger. Our ionic bond is more stronger than covalent bond. If the bond is more stronger, that means high melting point and high boiling point. So the answer will be 1. Very simple it is. Due to very high force of attraction or due to a strong bond. Moving to the next. Let me know if you have got any doubt or anything. Very good, Rishita. The first answer that you gave me, among the following, which compounds will show highest lattice energy? Lattice energy directly proportional to charge and lattice energy inversely proportional to size. If size decreases, lattice energy increases. This is the factor on which lattice energy depends. Now you can see KF, NAF, CSF, and RBF. Na is the smallest one. If size is small, fluorine is common in all of them. So lattice energy will be the maximum. So the answer is B. For the next one, you can see the correct order of lattice energy is given by NAF, NaCl, NaBr, NaI, NaCl. Na is common in this. So fluorine, chlorine, bromine, iodine. You know which one is the largest one? Iodine. If this is largest one, lattice energy decreases. This is the smallest one, so it will have the largest lattice energy. So the answer will be 1. Is that clear?
Yes, sir.
Third is also not correct. Covalent character we do generally it by Pajan's rule. Have you heard of this Pajan's rule? Yes or no?
Yes, sir.
So what does Pajan's rule says? So polarizing power inversely proportional to size of cation. Size of cation. Polarizing powers is inversely proportional to size of cation, or you can write polarizing power directly proportional to covalent character. More polarizing power, more covalent character. That means covalent character is also inversely proportional to size of cation. Or we can write covalent character directly proportional to charge on cation, charge or charge, whether it is positive or negative. So you can see one thing, that is chlorine is common in all of them, right? So LiCl will have, Li will have +1, then beryllium will have +2, then boron will have +3, carbon will have +4. So you can see covalent character directly proportional to charge. That means whether it is positive or negative, positive charge +4. So it will have the maximum covalent character CCl4, CCl4, then BCl4, BCl, then BCl2, BCl2. And here this will not be the correct because it has been shown that LiCl is greater than BCl2, which is wrong. So the correct answer is third. Is that clear?
Yes, sir.
Okay. What about fourth one is also about covalent character. So you can see here Zn is same. So you are going for oxygen. Oxygen sulfur. As I told you, polarizing power inversely proportional to size of cation. And you can write it polarizing power directly proportional to size of anion. If we are going to talk about anion, the size should be greater. Okay. So, and polarizing power directly proportional to covalent character. Basically, when we talk about anion, we talk about polarizability, ability to polarize, ability to polarize. So I'm going to write it here, polarizability. You have studied this concept, right? So sulfur is more, so sulfur is larger. That's why sulfur is having more covalent character. Is that clear?
Yes, sir.
Yes, sir.
If you don't get it, let me know. I will explain each and every point about Fazan's rule. Lattice energy affects which of the following factors? If more lattice energy, more stronger the bond is.
Is it all of the above?
Yes, exactly. So basically, boiling point, melting point, stability. If boiling point is very high, that means it is more stable. You need to give more energy to break the bond. No, already did this. Let me know when you're done with this. Very good, Rishita. Second question wrong. And third is correct. Akib, no answer from you. It's very good, Rishita. So see, very simple it is. Iodine. You don't need to know the atomic number if you know from which group it is. So iodine is from fluorine, and fluorine has this S2 and P5 is in its outermost shell. So you know that this will be the situation. 2 electron and 5 electron. Okay. But we needed to calculate for iodine. So for iodine, this will be the also scenario, but for iodine, there will be d orbital, which is vacant. So you need to do two excitation. So you are going to excite this to this side and this to this side. So according to that, which option will be correct? Third one. Very easy. Triple bond, you know that single bond, 2 electron. In one bond, 2 electron. Double bond, more electron, 4 electron. Triple bond, this is, so total number of electron will be 6. In one bond, you have 2 electrons. So in 3 bond, triple bond, you will have 6 electron. Variable, which of the following bonds will have the directional character? Directional character shown by covalent bond, because there will be overlapping of orbitals, and due to that the orbitals, you know, p, x, p, y, p, z, there will be x's. That's why covalent bond. Variable covalency is exhibited by third period element, especially the non you know, the p block element, non-metal. So this will be the scenario. Is that clear?
Yes, sir.
Nitrogen does not form NF5. You know why? Second period element cannot expand its octet, and that's why they have to follow the octet rule, and they cannot make more than they cannot keep more than 8 electrons. So only because of it doesn't have d orbital. You should revise it before. Let me know when you are done with this. Can I change the
Yes, sir.
slide? Okay, please do this. Very good, Rishito. No, it's wrong, Akib. This is your bond, not a band. It is printing mistake. Very good, it's correct. Yes, it is correct, Rishita. Rishita, the question number second, you have given the right answer.
Okay, sir.
So very simple it is. The first question, which of the following compound does not exist? As you know that nitrogen cannot make 5 bond. So NCl5, it doesn't exist. According to VBT, when a covalent bond is formed between two reacting atoms, the potential energy should be minimum. Potential energy minimum, that means maximum stability. Now for the next one, which condition is not favorable? We don't need to say for the favorable, not favorable. Combining atomic orbitals have nearly same energy. Whenever an atom combine or orbitals combine, they should have same energy, same symmetry as well. And there should be maximum extent of overlapping so that the bond will be stronger. So you can see this is the not favorable condition. If the maximum extent is not, minimum extent if you are going to take, the bond will be very, very weaker. The force of attraction will be minimum. And there the force of repulsion will, uh, what do we say, dominant, and then bond will be broken, not formation. No bond formation will take place. Is that clear, both of you?
Yes, sir.
Okay, let's go for the next.
Yes, sir.
Oh, wrong it is. See, which of the following is correct according to VBT? Collateral overlapping. That means this overlapping. This is not a greater extent of overlapping. This is head-on overlapping is more extent of overlapping. But this is true that when n increases, that means bond length, or you can say bond atom is bigger. Atom is larger. Wait a minute. Bond length is greater. And you know, bond length, where it is? Bond length. When we are going to talk about bond length increases, bond strength decreases. They are inversely proportional to each other. So when principal quantum number increases, that means it is having more greater bond length. That's why as the value of n increases, bond strength decreases. This is correct one. Rishita, if any atomic orbital is full filled, why it will, how it can overlap and
Sorry, two half-filled orbitals.
half
I
filled
meant two.
orbital? Yes. Okay,
Yes, sir.
tell me the answer.
I don't know, sir.
Do you know if fluorine is this much and another fluorine is this much? This is the bond length. Let's say iodine. Iodine is a very bigger. This iodine is very bigger. So when distance increases, the bond length increases, bond strength decreases. Yes or no?
Yes, sir.
When you are going to do the configuration of this, you get 1s to 2s to 2p5. And when you are going to do for chlorine, it will be 3s to 3p5. For fluorine, it will be 4s to 4p5, and this will be 5s to 5p5. So n increases, so bond strength decreases. Bond strength decreases or not?
Yes, sir.
So that's why second is the correct answer. Very good, Rishita. And which type of, you know that when you are going to do, this is hydrogen 1, hydrogen 1. This is how you did in class 11 at 10th, right? So
Yes,
in
sir.
one orbital, half filled it should be. If in a box only one electron will be there, another box on electron, then they will overlap with each other. That's why half filled orbitals take part in overlapping.
Yes, sir.
Do the next. Very good, Rishita. For 7-1, 2 is the option. Sixth one, see, very easy it is. If x-axis is internuclear, SS will always form sigma bond. 1s and p will always form sigma bond. SS will always form sigma bond. So 2py, if internuclear axis is your this x, and 2py come into parallel overlapping and it forms pi bond. The axis on which bond formation takes place. And 7, which of the following a statement regarding covalent bond is not true? Half filled orbital participant, this is correct. Bond is non-directional, not true. Bond is not. I told you covalent bond. Covalent bond is directional, so this is not true. A sigma bond is formed by overlapping of SS orbital alone. That is wrong. SP can also form sigma bond. S and P orbitals alone, that is also wrong. SS, SP, PP, that is all correct. Along internuclear axis. So this is the correct. PP orbitals along the side, no. Along the side it forms pi bond. Can I change the slide?
Yes, sir.
Yes, sir.
Very good, Rishita. Oh, very good, okay. Very good, Rishita. 1, 2, 3. All are correct. Very good. Oh, very good, Rishita. Akib, the third is not correct. Geometry of sp3 is tetrahedral. For sp2, it is trigonal planar. Geometry of sp3d, that is trigonal bipyramidal. And trigonal planar geometry belongs to which hybridization? That is sp2. On the basis of hybridization, 1s and 1p. So this will be mutually 180 degree or something like that. So the answer is 2. Is that clear, Akib?
Yes, sir.
Okay. Very good, Rishita. Very simple it is. Very good, Rishita. The seventh, up to seventh, you are right. Very good. Any answer for you, Akib? So okay, see, I'm going to explain. Octahedral, that means sp3d2. You have to remember this. Sp, the geometry is linear. Sp2, it is trigonal planar. Sp3, tetrahedral. Sp3d, trigonal bipyramidal. Sp3d2, octahedral. Sp3d3, pentagonal bipyramidal. Pentagonal bipyramidal. Now, how to calculate hybridization? Hybridization, if you know the structure, very simple formula: sigma bond plus lone pair. Sigma bond plus lone pair. LP. Sigma bond plus lone pair. Now see, if the sum of this sigma bond plus lone pair is 2, then it is sp. If it is 3, then sp2. If it is 4, then sp3. If it is 5, then sp3d. If it is 6, then sp3d2. And if it is 7, then it is sp3d. Hybridization state of AlI3. You know, AlI3. Only 3 electrons in the outermost shell of aluminum, and all are busy in bonding. There is no lone pair. So lone pair will be 0, and sigma bond, single bond, all the single bonds are sigma bond. So 3, the sum become output to be 3. So the hybridization will be sp2. Come to this, by hybridization we mean the mixing of electron. No, we don't do mixing of electron. Basically what we do is atomic orbitals. We do atomic orbitals mixing like this. This is the p orbital mixing, p orbital, orbital we mix. Okay, hybridization of SiCl4. Write the structure. You know, silicon is 14th group element. It has 4 electron in the outermost shell, and all are busy in bonding. There is no lone pair. And how many sigma bond? 4, because it is all 4 single bond. So sum is 4. That means it is sp3. Hybridization of SO3. Whenever oxygen is there, you are going to make double bond, double bond, double bond. Sulfur is 16th group, and it has 6 electron in the outermost shell, and all the 6 electrons are busy in bonding. 0 lone pair plus how many sigma bond? Whenever double bond comes, 1 sigma, 1 pi. So this is your sigma, this is your pi, this is your sigma, this is your pi, this is your sigma, this is your pi, this is your sigma. Sigma is 1, 2, 3. So sum out to be 3. So the hybridization will be sp2. Hybridization of SF6. See, 6 bond it will make, and you know, sulfur is 16th group, and 6 electron is in its outermost shell. All are busy in bonding. 0, and single bond it is making 6 single bond. 6 sigma bond it is 6. So it will be sp3d2. So the answer will be this. Is that clear, Akib? Okay. Sulfate ion, you should know the formula of sulfate ion first. Sulfate ion is SO4 minus 2. Write the structure. The structure is OO, 4 oxygen is there, and 2 negative charge, so distribute it equally, minus 1, minus 1. When oxygen has negative charge, it will form single bond. Otherwise, it will be double bond. Now count the double bond. Sigma, sigma, sigma. In double bond, one is sigma, one is pi. And sulfur is making 6 bond, so no lone pair. How many, what is the sum of sigma bond and lone pair? 4 plus 0 is lone pair, so 4 it is. That means sp3. Sp3, that means tetrahedral. Please do the rest. I told you sp3, that means tetrahedron. You need to draw the structure in order to calculate this. Okay. Take this screenshot. This will be